So this is the review for the systems guide for the algebra section in 8th grade, and pre-algebra section for that matter. So remember, systems are when you have two equations that you want to solve for. You want to solve for the x and y in both, and in order to do that requires some certain procedures. So it's a little different than solving one equation, because in one equation you have one variable, usually x, that you're going to solve for. In a system, you have two equations and also usually two variables that you're going to solve for. And remember, when we're solving for a system, what that really means is that, remember, each of these equations represents a line in the graph. So we're solving for the point where these two lines cross. So we're solving for that point right there. So in every problem, there's going to be two lines given to us as an equation, and we want to solve for them to see where they would cross on a graph. So that's what we're doing here algebraically. And most of the time, the easiest way to comprehend this is by using something called elimination. So elimination is when you want to get your two equations to be in such a way that you can actually add the two equations together and eliminate a variable, get rid of a variable, and then focus on just one variable at a time rather than two variables at a time. So it goes a little something like this. So for number one, this one's a nice problem because it's already set up for us. So the goal for elimination is that you're going to add the two equations together, and after you add them together, one of the variables should completely go away. So in this case, the y variables will completely go away. Because positive y, let me erase that a little bit so I can see again. So positive y plus negative y just becomes 0, goes away. And then negative 2x plus 4x is going to give me positive 2x equals, and then 10 plus negative 14 is negative 4. So you see, after I add, one of the variables completely cancels out, and I'm just left with one variable now. So now instead of working with two variables, I can work with one variable, and this equation I can solve because I can just divide 2 on both sides, and I get x is negative 2, which is half my answer. So remember, your answer should be a point. It's a point on the graph. So a point needs to have an x-coordinate and a y-coordinate. And I just found my x-coordinate. Now I need to find my y-coordinate. So what you do is, once you have one of your numbers, whether it be x or y, once you have one of the variables solved for, you're going to take that answer and plug it into one of the two equations up top and solve for the missing variable there that way. So for example, this top equation right here says negative 2x plus y is equal to 10. Well, I know what x is. I know that x is negative 2. So instead of saying negative 2 times x plus y is 10, I'm going to say negative 2 times negative 2 plus y is 10. And this, again, is an equation I can solve for now. Negative 2 plus negative 2 is positive 4. And then subtract 4 on both sides, and you get y equals 6. So my answer, my point is negative 2, comma 6. That would be the point where these two lines cross. So again, elimination means add them together so that one of the variables cancels, solve for the one that's still remaining, and then plug it back in to solve for the one that you didn't get the first time. It's a little bit of a long procedure, but again, the more you do it, the more you get used to it. Now, this was an easy problem because it was set up for us. Something like number two is not set up as nicely for us because I can't really add these together right now, because one of the rules for elimination is that your equations should be in what's called standard form, which means that your variables should be on the same side as each other. So the x and the y variables should be on one side, the non-x and y numbers should be on the other side. Well, in the first equation is that way already. 7x, 5y, they're both on the left side, negative 24 is on the right side. So my variables are on one side, my non-variables are on the other side. We're good there. This bottom equation, though, not so much. This bottom equation has a 5y on the left and a 9x on the right. That can't happen. My variables should always be on the same side as each other. So in order to fix that, I'm just going to subtract 9x from both sides. That way I can move it over here and make this equation into, I'm going to put the 9x up front, so negative 9x plus 5y equals 18. Now it's set up because I have an x and the y on the same side, just like I have up here. So I'm going to rewrite my equations on top and bottom of each other. So 7x minus 5y equals negative 24. And negative 9x plus 5y is equal to 18. And now I can add them together, because when I add them together, Negative 5y plus 5y, that's just going to cancel out. 7 plus negative 9x is negative 2x. Negative 24 plus 18, again, remember your sign rules, it's going to be negative 6. And then again, I can solve for this now. Divide by negative 2, divide by negative 2, and I get x is positive 3. Now, again, that's not the end of my answer, though, because I need a point. So I'm going to take this positive 3 and plug it back into, I'm going to do the bottom equation right here. Plug it back into this equation right there. So 5y equals 9. Now, instead of saying 9x, I'm going to say 9 times 3 plus 18, because I know that x is 3. Then I'm going to simplify a little bit. So 9 times 3 is going to give me 27 plus 18. Haven't done anything with the 5y yet, so I'm just going to bring that down. And then 27 plus 18 I'm going to put together. Again, I'm just going to do normal 27 plus 18. I'm not moving them across the line, so just keep doing it as normal. 45. 5. Now there's nothing more to simplify, so now I'm going to solve. So I'm going to take this 5 and get rid of it by dividing. Do that on both sides. And I get y equals 9. So my point then would be 3, 9. That would be my final answer. So again, you have to do a little bit of setup every now and then. We're using the elimination method because it won't always be set up for you automatically. Now, this next one's close to being set up because my variables are on the same side. They're both in standard form. But if I add these together right now, 2x plus negative x is x, 6 plus negative 4y is positive 2y, and then this would be 36, 36 plus negative 27, or sorry, plus negative 25 will give me, again, it really doesn't matter, but will give me 11. Had a little brain fart there in figuring that out. But I have a problem here because the variable isn't canceled yet. I still have x and y both. So when I add together, one of the variables should completely go away because I can't solve for this. I can't solve this right now because I have two variables still. So what you can do in order to avoid this is when you have a situation like this, you can multiply either one or both equations by a value so that one of your variables would cancel. So for example, this x right here, this is a negative x. If that was a negative 2x, it'd be good, right? Because 2x plus negative 2x would be a 0, and then I'm good. So if I could make that negative x into a negative 2x, that'd be the best. And I actually can. I can just simply multiply this entire equation by 2. Now, I can't just multiply the negative 2x by 2. I have to multiply the entire equation. So when you change something, you have to change the entire equation in the same way. So 2 times negative x is negative 2x. 2 times minus 4y is minus 8y. And 2 times negative 25 is negative 50. So I multiply the entire equation by 2, not just the x number. And then now, if I write my top equation below it, 2x plus 6y equals 36. Now when I add them together, it's all good because my x's will cancel. Negative 2x plus positive 2x goes away. So very often you will need to multiply one or both equations by something so that when you add them together, one of the variables will go away. And then here, negative x plus 6 would give me negative 2x. Or sorry, negative 2y, my bad. And then I have negative 50 plus 36, which would give me negative 14. Then divide by negative 2, and I get y is equal to 7. So yes, you can get y before x. That's perfectly fine. All you need to do now is just go back and plug it in. I'll go ahead and plug it into this top one here again. So it'd be 2x plus, now instead of saying 6y, I'm going to say 6 times 7 equals 36. We do some arithmetic here. 2x plus 42 is equal to 36. Subtract 42 from both sides. You get 2x is equal to 14. Then divide by 2, and you get x is equal to 7. Now, I did make a mistake here. I don't know if you caught it yet. Is that 36 minus 42 is actually not 14. I'm not sure why I did that. Always good to check your work. It's actually going to be negative 6, so that when you divide by 2, it's going to give you negative 3. Again, a little bit of a brain fart there, my bad. Also, it should have been negative anyway because the 42 is bigger and it's negative, so you have to carry down the negative sign. But I make mistakes too quite often. Just make sure I catch them. And so my answer would be negative 3, comma 7. So again, you can solve for your y first. That's fine. Perfectly okay to do so. Just make sure that when you add together, your variables will cancel. Number 4, again, same way. This is not in standard form yet, so I'm going to add the 3x to both sides to get it into standard form. So I'm going to have 3x plus y equals negative 14. And notice I added the 3x because it was a negative 3x over here, so I add to move it. And then I have negative 4x minus 2y is equal to 18. Now, I could do this a few different ways. Just to show you that you can multiply both, I'm going to do it a different way than some of you might have initially thought, is that I'm going to try to get my x's to cancel again. I want to get my x's to go away. So right now, this is a 3x and a negative 4x, which doesn't work, because 3x plus negative 4x is negative 1, not 0. So I have to think, what number can I change both 3 and 4 into such that one's positive and one's negative, so when I add them together, they cancel. And the number that comes to mind is 12. I can change a 3 into a 12 by timesing it by 4. And I can change the negative 4 into a 12 by timesing it by 3. Now, this will be a negative 12, which is still okay because I want one of them to be negative. That way when I add, they'll cancel each other out. So I'm going to multiply everything in here by 4. So 4 times 3, it's 12x plus 4y equals 56. And then down here, I'm going to multiply everything by 3. So it's negative 12x minus 6y equals, and then I'm going to do 18 times 3 as well. Don't forget these n numbers. That's going to be 54, by the way. Don't forget to multiply these n numbers too. A lot of people forget that and it throws their answer off. So make sure you multiply everything in the equation by the value you're multiplying by. You're going to add these together. X's go away. 4y plus negative 6y is negative 2y. And then 56 plus 54 is going to give you 110. And then I did make a mistake here once again, making a lot of mistakes today, is that this is a negative 14, so that should be a negative 56, which is going to change this into a much easier to do negative 2. So one thing you can be aware of there and kind of learn from my mistake is that if you get a number that's really big and you're kind of like, this probably isn't what they were looking for there, just go back and check your signs. It could be that you just have a really big number, but it could also be that you missed a sign mistake like I did there. So. And then you divide by negative 2, and you get y is equal to 1. Assuming I didn't make a mistake there, which I don't think I did. And then I'm going to plug that back into the bottom equation for me. So I'm going to take this equation, negative 4x minus 2. Whoops, I forgot to write the x there. Negative 4x minus 2 times 1 equals 18. Then I'm going to solve for this. So negative 4x minus 2 times 1 is just 2 is equal to 18. Add 2 to both sides. You get negative 4x is equal to 20. And then divide by negative 4, and you get x is equal to negative 5. So my answer would be negative 5, comma 1. So again, I messed up my sign there, but caught myself and hopefully corrected it well. So. Again, these problems take a while to do if you're not used to them. So the more you practice, the more comfortable you get, the easier it comes. But the goal is to get the setup right because the actual arithmetic isn't that hard, but it has to make sure you have the right setup so that when you add them together, your variables cancel and you can go smoothly throughout the rest of the problem. On the back side, we have an example of a word problem or two using this method here. So for these word problems, again, the key lies in the setup. You have to kind of read the problem carefully and set the equations up right. That way, when you do your elimination method, everything falls into place. So it says here, James buys 3 goldfish we'll call G, and 2 beta fish we'll call B, and pays $7.20. So let's write that as an equation. 3 goldfish plus 2 beta fish equal $7.20. And then Mark here buys 5 goldfish and 1 beta fish, so just B, and pays $8.85. So now I have my 2 equations set up. I want to figure out how much each type costs. I want to figure out what is B and what is G. So now I have my 2 equations set up. I'm ready to go. So they're both they can't add them together yet, because if I try to add them together, the g's won't cancel, nor will the b's cancel. But this b is a 1b, right? If I could make it into a negative 2b, that would cancel with the positive 2b up here. The negative 2b and the positive 2b would go away when I add them together. So I'm going to multiply this entire bottom equation by negative 2, because I want the b to be a negative as well as a 2. So I get negative 10g, make sure I don't make my sign mistakes here as well. And then I have plus negative 2b. And then again, don't forget to multiply out your n numbers as well. Again, a lot of people do, just don't forget. So it'd be negative 17.7. And then I'm going to do the same thing to the top. I'm just going to keep the top the same, actually. I don't need to multiply anything to the top because the b is already set up for me. So 3g plus 2b. I like to keep my equations top and bottom like this, though, because it makes the adding part a little easier. So now we're going to add them together. 3g plus negative 10g is negative 7g. This just goes away because the b's cancel, which is what I want. And then 7.2 plus negative 17.7 is negative 10.5. And then I'm going to divide this by negative 7 to get my g by itself. And I get g is equal to 1.50. So that's how much a goldfish costs. Now I need to figure out how much a betta fish costs. So I'm going to take this goldfish number and plug it back into one of these equations. I'm going to pick the bottom one here. So 5g, which is now 5 times 1.5, plus b equals 8.85. And so I'm going to do 5 times 1.5 is 750. And then again, bring everything else down. Don't forget to write your work. And then subtract 750 from both sides. And I get b is equal to, and if you take 855 minus 750, or sorry, 885, my bad, almost did that wrong there, you get $1.35. So one goldfish costs $1.50, one betta fish costs $1.35. So again, you have to read the problem, set up your equations correctly, figure out what you need to multiply by, if anything, and then do your procedure just like you did on the front page. But it all requires a good setup. Number 6 is done the same way, just different numbers. So we have, we'll call this X and P. So 2 Xbox games plus 3 PlayStation games is 1555. And then 3 Xbox games plus 4 PlayStation games is 2190. Whoops. 90. I need to figure out how much is one Xbox game worth and how much is one PlayStation game worth. Well, in this case, they are in standard form, but I can't really just get by multiplying just one of them. So I have to multiply both of them by something. And in my case, I'm going to try to cancel out the x's. So I'm going to say, okay, here's a 2x and here's a 3x. What number can I change them both into? And the number that comes to my mind is 6. 2 times 3 and 3 times 2. Now I want one of them to be negative, so I'm going to make the top one negative. So I'm going to multiply this top one here by a negative 3. That will get me a negative 6. And the bottom one here by a positive 2 to get a positive 6. That way they'll cancel when I add. Again, one of them should be negative, one of them should be positive for the ones that you're going to cancel. So here, negative 3 times 2 is negative 6x. Plus, and then negative 3 times 3 is going to give me negative 9. And then that'd be p. And then 1550 times negative 3 will give me negative 46.65. And then you're going to multiply the bottom one by 2. So 2 times 3, x is 6x. 2 times 4p is 8p. And then 2 times 21.9, again, make sure you multiply those end ones, is going to give me 43.80. Then I'm going to add these two together because now the x's will cancel, which is good. Negative 9 plus 8 is negative p. And then make sure you add the n ones too. Again, another common mistake people forget. And that will give you negative 46.65 plus negative, or probably plus 43.8 will give you negative 2.85. And then again, you can't have a negative p, so you're going to divide by negative 1. And that will give you p is 2.85. So that's how much PlayStation game is worth. Now I need to figure out how much an Xbox game is worth. So I'm going to plug this back into the top one here and go through my procedure. So plug in P there. Again, everything else stays the same. And you can pick the top or the bottom equation, doesn't matter which one you choose. And so then I can multiply this out here because I know what 3 times 2.85 is. Again, you don't want to move anything until you have everything on one side squared away. So 3 times 2.85 is going to give me 8.55. Bring down the 2x and the 15.55. And then you want to solve for x, so you're going to subtract the 8.55 first. That'll give you 2x over here. And now you're going to subtract 15.55 from 8.55, which gives you a nice even 7. And then divide by 2, and you get x is 350. So again, you're not really finding a point in this case because it's a contextual problem, but you still need to have two answers, one for the first and one for the second. So again, the trick lies in the setup, and again, sometimes you'll need to multiply both equations by a number like we did here. Sometimes you'll only multiply one of them by a number like what we did up there. Sometimes it'll be a negative number, sometimes it can be a positive number. It just matters of what the setup requires. So making sure you get that setup down is critically important so that the rest of the problem goes smoothly. That's it for this one. Hope you enjoyed the video. Have a good day.